Okay. Here we go.
Looks fine. So I can see you, I can hear you, I can see the slide. Perfect. So welcome again, Viktor. And yeah, the stage is yours.
Thank you. So thanks for everyone who is listening. As I'm thinking whether I should give a quick answer to your introductory question, whether we can do better than simple Terraform pipelines, and the answer would be yes, but let's see what actually GitLab offers in this space, because that's what the presentation is about. If you have any questions, feel free to reach out to me. You can find my contact details on the current slide. And actually, let's get started. So, yeah, what is infrastructure as code? I'm sure that you've heard a great definition in the previous presentation. I won't go into too much detail for this reason. Instead, I'm more focusing on the tool set here and the very rough overview of what do we mean by infrastructure as code. There are various parts of it, and you can see plenty of tools in this space. I presume that you are familiar with at least some of them. But the basic idea is that you describe some parts of your infrastructure in code, in configuration files at least, but preferably not just configuration files, but more evolved tools actually. What GitLab offers for a long time is, and is rated to infrastructure as code, is the pipeline itself, which can run any kinds of scripts basically, and you can do all kinds of deployments using it. We offer as well a container registry, so you can run a containers workflow, and all this is related to infrastructure as code, I think. But actually, we have more than this, and we have a few recent additions to GitLab. So, in order to understand what we're focusing on, I think it's important to understand how we see the trends, how we see the industry developing itself. First of all, something not totally new thing is the containerization is basically everywhere, and more we are thinking about ephemeral containers instead of VMs. And this is a very important change in mentality, because if you look back at the previous slide, where we have Vagrant, where we have Packer, or where we have even the configuration management tools, Chef, Puppet, Ansible, these are extremely great tools to create an AMI with Packer and to configure that AMI or the VM itself with Ansible and Puppet and friends. But actually, if you are running containers, these tools become a little bit less important. They are still important, but a little bit less important. The other trend that we see is this shift to the left, basically, software development mentality in operations that was probably not first, but it was definitely became public or greatly appreciated with the SRE movement presented by Google. And together with software development mentality appearing in operations shifts to the left more and more towards developers. And all of this happens together with the cloud transition. And one very interesting fact that I've seen whenever I was running user interviews is I always ask them when I do user interview on Terraform that when did they introduce Terraform in the company? And until now, the answer was always when they moved to the cloud. So to manage a sizable, not a huge, but just a little bit sizable infrastructure that's built in the cloud, you will likely need infrastructure as code tools, because it's just much easier than the point and click solutions that the providers actually offer. And all of this together just leaves us with automation remaining the king, which is there for a long, long time. And actually, I think as us software developers, things automation should be the rule. So automation remains the king. And this is the trend that we have ephemeral containers, more and more software development mentality in operations, more and more operations done by developers. So we have to make it easy. We have to make it simple to understand by developers. There's the cloud transition that actually requires some kind of automation, and it's much more developer friendly to use APIs than the UI of the cloud provider. And all of this can be automated, which is great, because who likes repetitive tasks and error-prone tasks? So the question is, how can GitLab actually help this? And we have, as I told you, container registries inside GitLab for a while. And the next step, as we see, is to add support to Terraform. The reason why we choose Terraform is, first of all, because of the trends that we see. And I like a lot this quote I have from one of the analysts when I was running an analyst interview, and I tried to challenge our own assumption to starting with Terraform. And when I asked him that, are there any strong contenders for infrastructure provisioning who would try to beat Terraform? And even though there's Pulumi and a few others, his answer was basically that Terraform is de facto standard in infrastructure provisioning. I think of it today as what Docker is for containers, Terraform is for infrastructure provisioning. It's a really great tool, and if you are not familiar with it, I can hardly recommend trying it out. So currently, our focus is around Terraform to provide a really awesome developer experience and operator experience for Terraform users inside GitLab. You can run various configuration management workloads inside Terraform as well. Like Terraform has an Ansible provider and Chef as well. But we are not speaking about that right now. It's really only about Terraform. If you are not familiar with Terraform, I would like to give you a very, very short introduction to it. If you are familiar, don't blame me for this introduction. So first of all, it's an open source project by HashiCorp, and we are very grateful for this project. It's really great, and we like to work with HashiCorp a lot. And as they described it, basically it's a dependency graph of resources that describe the current state of your infrastructure. And this is the basic idea of Terraform. You define your infrastructure in one file, or actually several files, and the dependencies in between, like you need a given IAM role to be attached to a given virtual machine that will actually use a container to be deployed on top of it, and so on and so forth. As a result, as it's not provided by cloud providers, but by the open source community, actually there are plenty of providers that leverage vendor APIs. This is the biggest critic around Terraform as well, that some of these providers might be of low quality, but basically if you pick a well-known cloud provider, then you should expect its Terraform support to be of first class, so no problems usually there. And at the core of Terraform is a state file. This state file will store the information that's described in your code and that was applied to your infrastructure. This means that you have the code, you have the infrastructure, and in between there's a state file that's known by Terraform. Terraform tries to keep it updated, and it will tell you if it manages to figure out configuration drifts, but actually the basic idea is to change the code, diff it with the state file, and then apply the changes to your infrastructure. And this is what Terraform does amazingly well. Clearly, you have to store the state file somewhere, and a little bit later I will speak about this, how it actually happens. By default, Terraform allows you to store the state file locally. It's not recommended to put the state file in a Git repository because it actually contains credentials, likely to contain credentials, and it's not encrypted by default. On the other hand, if you want to work with a team, local storage is not a good option. So there are remote storage options for state files. One such storage option is inside GitLab, or you can use it you can store the state file in S3 or whatever other object storage you like, because Terraform supports basically many of these. And how do you run, which are the core commands around Terraform? I'm mentioning here 2 commands. Clearly there are more than 2, but these are 2 most important ones. Terraform plan shows you the changes that are expected to happen to your infrastructure, while Terraform apply applies the current infrastructure's code to your infrastructure, updates the state file accordingly, and the next Terraform plan or Terraform apply will run against the new state file. This is how it looks in action, the Terraform plan output. You can see here that it would create a resource named Heroku app. No, actually, it could a resource Heroku app called production. And there are many, many details of it which will be known only once we run Terraform apply, like the web URL, for example. What can we do with GitLab that is better than the pipeline that I have just shown you? Because actually this is a screenshot from a GitLab pipeline. We realize that we can do a lot of things. I will show you 2 use cases here. The first one is setting up a new Terraform project. A typical workflow outside of GitLab is the following. Let's assume you would like to store your state file in S3 and you would like to use DynamoDB to lock that state file, so there won't be concurrent writes and reads around the state file and it will be safe. And you want it encrypted as well. So what you need to do first is write a piece of Terraform code that describes the S3 buckets and the DynamoDB. Then you run Terraform apply to create the S3 bucket and the DynamoDB table and to connect the two. After that, as a first step, you have to update your code to say that, okay, from now on, I don't want to use the local state file that was used during the first Terraform apply, but I want to switch to the S3 backend as a state file storage that I have just created. Then you apply the changes actually, and the local state moves to your remote state file in the S3 bucket. You can describe all the access rights around this S3 bucket as well inside the infrastructure's code, so inside the Terraform file that you have, and you will have to create your infrastructure as well. So basically you had 5 steps just to get to a point where you can start writing, start defining your own infrastructure. And you have to repeat this every time. It's error prone, it's time consuming. I've heard many users who are starting to use Terraform to don't really like it. We thought that we can do something much better inside GitLab, because GitLab stores your infrastructure code project by default. So what if we could use GitLab as the backend storage for the state file? And inside the GitLab pipeline, we know whether you are authorized to read or write the state file. And you just have to take care of writing your infrastructure, basically. So in the end, what we came up is an extremely simple first step to define the backend, because it still has to be defined. In the typical workflow, you had to define it twice. First, a local backend, the default backend is used, and in step 3, you have to change it to a remote backend. Here, we have to define it first. Then we provide you a GitLab CI YAML file that can use this backend out of the box and a few more niceties as well. And in step 3, you're free to write your infrastructure, and you just write git commit and git push in the end. The pipeline will run as defined in step 2, and your infrastructure will be managed. So we think that this makes the previous process much more smoother and much simpler to use. And as a result, we expect that actually people will be more willing to define the infrastructure code, because it's just much less time consuming and much less error prone. And all this uses GitLab's project roles for authorization rights around the state file. So you don't have to think about it, whether you've done it right or not. If you know that somebody is a maintainer, they can write the state file. If somebody is a developer, they can read the state file. As these are relatively new features, we plan to add more customization options around the authorization rights, but by default, this is the setup, and it just works out of the box with GitLab, both self-hosted and on gitlab.com as well. The second use case that I would like to present you is around collaboration around infrastructure changes. It's very, very important it's a very tricky thing actually, because merge requests are the place to review changes inside GitLab. But in the case of infrastructure code, users are not interested only in the code changes that are happening, but I would even say that we are more interested in the infrastructure changes that are expected based on those code changes. And previously, the only way you could do is to either use a third-party tool to get a simple overview, or you had to dig into your pipeline job logs to see the output of Terraform plan. And when I was running user interviews, I could see all kinds of hacks around this, where really people coded various bash scripts to get the summary of the changes to be sent over to Slack so they know whether they have to look into it or not, while everything is in the merge request and it should be there. That's what we think. So we came up with an extremely simple widget in the merge request that requires almost no configuration from your side. And it shows you the summary that there is one change to be expected. There is nothing, no infrastructure resource to be changed. And one resource will be actually deleted. No resources will be deleted in this case in the image, as you see. So this is something that I've heard from many of our customers that they wanted to upgrade their GitLab instances because they wanted to start using these Terraform features. And to set it up, it almost takes you just these 4 lines of code. Actually, there's a 5th line as well to create the JSON plan file. But these are all that's needed. And again, if you are using the Terraform template that GitLab provides, you can get these features out of the box. So I think these are 2 core features. And we started with this, the next iteration around adding improved support for infrastructure as code workflows in GitLab, but actually we have more planned. In our current pipelines, we have still improvements on the GitLab Managed Terraform state. It was released in the last month, and we know of a few bugs. And as well, we want to add more tooling around if a lock is stuck, you don't have to use local commands, but a UI to unlock the state file, or add extra tooling so that you can manage the state file in a more friendly way and you can feel that your data is yours and you are secure. In the second step, we would like to add a Terraform module registry. Terraform has amazingly good support for modular design, which I think is crucial for well-architected infrastructure. Because often we think of infrastructures having standardized layers, standardized aspects, and especially in bigger organizations, it's very important to reuse a proven code base that's checked by the most expert infrastructure people in the organization, and developers who are still responsible for the infrastructure can just use Terraform modules. So we'd like to provide you a Terraform module registry inside the set of module registries already available inside GitLab to make this easier for you. And the third step, we would like to provide even better infrastructure templates in general around Terraform, so that we have project templates and that you can use to get started with all kinds of projects. We want to have similar templates for you for Terraform, even for modules and for the final project that can leverage the best practices around GitLab and Terraform. And in the end, all of these are actually saving time for you. For example, one thing that we are planning to have is moving the current Kubernetes cluster creation under Terraform. This would allow a much more flexible instantiation of clusters. And once you have your cluster, you can change it as you like using Terraform. We see that even today, quite a few of our customers are using Terraform to spin up Kubernetes clusters. So this should be in support of them. But even if you are not familiar with Kubernetes, you will get a fully functional cluster with just a few clicks, as we have it today with GitLab as well. And as you gain more experience, you can change that Terraform template and update your cluster as you like. We have topics, we have ideas for other providers as well in the last, not just Kubernetes, but later for various AWS architectures, for example. So these are our current plans and the current features that GitLab already provides for more than pipeline runs of Terraform. And if you have any questions, I'm here to answer them.
Thank you very much for your presentation, Viktor. Yes, indeed, we have a few questions in. So as we have a few minutes left until the next session starts, let's start right with the questions. So the first question was, did you come across on some problems with parsing plans file with JQ? I mean, JQ, for example, being unable to parse that file to create a JSON report.
Yes and no. So if I've come across situations where you have to have a special JSON output specified in the Terraform plant command in order for JSON output. And in these cases, I never saw that JQ couldn't parse the JSON file. But I see the question here. If you have a concrete example, just please send it to an issue, ping me on it, and we will investigate what can we improve there.
All right, super. Thank you very much. The next question would be, what is the difference between a Terraform module registry and the GitLab project?
Very great question. So what the GitLab project is actually a huge set of features around the Git repository. The Terraform module registry is a very different thing. I would describe it right now with looking at Docker registries, for example. You have a GitLab project that has your application code and it has a Docker file in it. And when you run your pipeline, you can publish the final Docker image to your registry, and others can reuse the Docker image itself. The same goes with Terraform. You have a Terraform code, a Terraform module code that is published in the registry. Why it's better than using the Git access to modules, because actually Terraform supports Git-based access to modules as well. It's mostly because of versioning. In the case of the Git access, you can reference a given tag or even a given commit hash, but actually with the registry, you get samware versioning, semantic versioning, which means that who is responsible for the module, like in a larger organization, they can freely update the modules, they can upgrade, they can bump version numbers, minor version numbers, or patch version numbers. And if you are fixing your reference to the module on the major version number, you will automatically get all those updates. While if you are using a Git-based module reference, then actually updating the module won't have any effects on you, and you have to follow all those updates manually.
Mm-hmm. All right, thank you. The next question goes more into the direction of security. So the question is, where does GitLab store the state files, and how secure is that storage?
Again, very good, and I'm thankful for this question. If you run a self-hosted GitLab instance, then the state file storage can be configured in your GitLab instance, and it's totally up to you to basically to whoever manages that bucket or that storage to secure it. On GitLab.com, we have a separate object storage just for the state files, so it's not shared with anything else. It's encrypted by default and versioned, and it's under GCP.
All right. Following up on the storage question, an attendee asks, can I use the Terraform backed state storage with local Terraform runs?
Yes, you can. In that case, you need a bit more details in the Terraform backend definition. And I will share again my screen because I have one more slide here, which is our documentation slide, a link to that. This specific use case is described in the documentation.
All right, cool. Thanks for sharing. Well, I think that's all questions that I see for now, which kind of fits with the schedule. So, well, thank you for your presentation, Viktor, and for going into the questions. Thanks for joining us during the event.
Thank you very much.
All right. Bye-bye, Viktor.
Bye.